We're talking about software architecture. Did you ever have a class that talked about software architecture? Did we talk about software architecture before? Did we have a class? Well, we talked about models, right? We talked about software development models, right?
Yeah.
What were the models? Do you remember the models? Some of the models? No, that's not a model. Waterfall is a model. Agile is not really a model.
It's a method.
Yes, it's right. It's a method. What another model? What's another model?
The spiral.
Spiral, another model. The
Yeah, those are the same.
prototype. Is that what you mean?
No,
Trial and error, right?
The next thing to say was prototype. The next
Prototype,
thing
well, you have to specify when you say prototype. You can't just say prototype.
there's another one.
You gotta say throwaway prototype
Word.
or not throwaway prototype.
Yeah.
And then incremental and. But there was one point I wanted everyone to understand, which was that. Some of these things, like the prototype one in particular, the throwaway prototype relies on using another model after it. Once you throw away the prototype, now you've got to still use waterfall or
Yeah.
V or spiral to continue the thing. And those are all models for development of software. Now we're talking about the software itself. How should it look when you look at it, when it's finished? What should the structure of it be? So in architectural design, we want to think about the overall organization. How is it decomposed into components? Are there servers? Is it on one computer or is it on many servers? What technologies will you use to build the software? There are many different interpretations of the term software architecture. Some focus on architecture as a noun, the structure of the system, and others consider it to be a verb, which would mean the process of defining those structures. In other words, how do you come up with a structure as opposed to what is the structure? Okay, the IEEE definition of software architecture. Architecture is the fundamental organization of a software system embodied in its components, their relationship to each other and to the environment. When we say its components, we mean like the software can be broken down into modules. And the relation to the environment means, does it use other systems? Does it interact with other pre-existing systems? Or existing systems that you created? Okay, and the process and the principles that guide its design and evolution. Okay, software architecture is components. A component is an element that implements a coherent set of functionality or features. So a component is like a subset of your program. Software components can be considered as a collection of one or more services that may be used by other components. When designing software architecture, you don't have to decide how an architectural element or component is to be implemented. In other words, it's a looking at the whole structure from far away. So you don't get involved with how the component is implemented, but you say what components will there be. And you use implementation of that interface to a later stage of the development process. Okay. Access to services provided by software components. So there's two choices. So you can be accessed through an API, or they can be accessed directly. What's the advantage and disadvantage of an API? Can anybody tell me? That's a good question. You have these two different ways of communicating between the components. Most of your programs that you've ever written were like this left-hand picture. You never wrote an API. What's the difference, or what's the advantage of an API, and what's the disadvantage of it?
Separation of concerns.
Okay, you have to explain that. A separation of concerns.
Small marriage.
Oh, I separated concerns by having this section and this section and this section. That separated concerns.
Are these hardware versus software also?
No, this is a software component.
So
There's 6 software components here. These I access through an API.
The advantage is this one, on the left, component 1 is that they buy faster. So you don't have to make.
Right, they're probably faster. True. And here was the advantage.
here, what's the advantage,
I mean, most people do have APIs, so
data protection?
kind of, you could have protection here also.
Right.
No, there's a basic concept in computer architecture or computer theory. I don't know how to say it better. Called abstraction. How does abstraction relate to this? The API call is an abstract call.
What are these slides, by the way?
They're in section 9 on under the first one, I think, addition or something, not the one that says Kokomo. We're gonna skip Kokomo this year. You see it there? So what would it mean to write an API? Anybody?
Just like a bot that other people could use, not a bot, but
What, say it again, a what?
you can ping somebody else's server for a piece of information.
Yeah, that's how you would use an API. What is an API?
An application programming,
Yeah, but what is it though?
what is it? It depends, is it a REST API, is it a SOM API? The way of
Well,
interacting with another software.
it's, yes, that's true. It's a set of function calls, let's say let's get most practical. It's a set of function calls that I can use to communicate with components. But I'll tell you the advantage. The advantage is that if I change the implementation, even the function names and the parameters of the functions, all of them, let's say I change every single function name and parameter in S2. Because I made it more efficient now. I've improved it. I don't have to change the API at all. The API, I mean, I don't have to change the interface. The user of the API doesn't have to learn anything new. The API will still have the same function names. But when those function names are called, the translation into the call to the component will have to be different.
Separation.
And maybe if that's what you meant by separation of concerns, it's actual abstraction. Because I put in a layer of abstraction. I'm talking to like a virtual function. It's a virtual function which calls another function.
Black box. So it's like, I mean, you don't know how.
Let's use it is a layer of abstraction. That is the term.
Okay.
That is the best term. Any other term will just explain it badly. It's not a black box. I mean, yes, S4 becomes a black box from the perspective of the higher level, but that was true over here also. S2 is a black box from the S1 and 2 are black boxes from the caller. Whoever calls them, they're all black boxes. But here I have to know the function name and its parameters in S1 and S2. In S4, I have to know the API's function name and parameters.
Gotcha.
And I have a new layer of abstraction. I'm calling a function, but there's no real function like that. That function just calls another function. So that's it. Now the API function calls could even be like what's her name in the back? Ruben? No? Yoni. Yoni, what's your last name? Yes, yeah, I thought so. Yoni, Ruben? Ruben, B-I-N, Ruben. So Yoni Ruben said, it's like if you call over, you're right, because it could be that the API call is not a function call itself, it could be just a sending of pieces of data, and then that will call the function. It doesn't have to look like a function call necessarily. It can look like an HTTP request, for example. Okay, these are two things. Why is architecture important? Architecture is important because the architecture of a system has a fundamental influence on the non-functional system properties shown in table 4.2, which is this. Which is these things, reliability, all these things. Architectural design involves understanding the issues that affect the architecture of your product and creating an architectural description that shows the critical components of their relation. Minimizing complexity should be an important goal for the architectural designers. The more complex the system, the more difficult and expensive it is to understand. Programmers are more likely to make mistakes, introduce bugs, security vulnerabilities when they are modifying or extending a complex system. In other words, you want an architecture that simplifies, not complicates. if you don't have any architecture, you're probably gonna have lots of function calls and it could be complicated. The idea of the architecture is like, what is the layered approach? The layered approach is that each layer is a subsystem, so I can understand it. All right, non-functional, so these are things that we want in our software. Responsiveness, which means does it react quickly? Reliability, does the system feature behave as expected? In other words, is it getting the responses that you're supposed to be getting? When it computes your tax return, does it do it correctly? Availability, can the system deliver its service when requested? Is it like on the 15th of April, is it not working because there's too many people asking? Security. Do other people get to see your tax returns? We don't want that. Usability. Is it clear to understand what to fill in each field when you're filling out your forms or whatever? Maintainability. If the tax rates change, can I change the system? Or is it all hard coded and very difficult to change? Or if I need to add a new feature. Resilience. Can the system continue to deliver user services in the event of a partial failure or external attack? If one part of the system gets attacked, will the other parts fail or will they keep working? Oh, so here they give an example of from Star Wars. A centralized security, so the influence of architecture on system security. So here they're talking about security, and they're basically talking about the question of where do you hide your valuables? In the Star Wars prequel Rogue One, which if you don't know what it is, here's a wiki page. The evil empire stored the plans of all of their equipment in a single, well-guarded remote location. A system like this is called a centralized security architecture. You put all your valuables in one spot. I told you the story about like, if let's say you can't lock your door on Shabbos because of it's electrical lock and you have money. So you leave your door open and you hope nobody will come into your room. But you also can't carry your money around with you because it's Shabbos. So what do you do? So what I figured out to do was to hide my money, but did I hide it all in one good place? No. I found like 8 places to hide it. So then if they find it, maybe they probably won't find it all.
So it's a little scavenger.
Yeah, I made a little scavenger hunt. Fortunately, nobody came in, but had they come in, they might have found one and said, oh, I found it. You see what I'm saying? They didn't necessarily even know that there were 7 other. Wow. That happened to me. I was like, what am I gonna do? I can't carry them. I don't want to stay in my room all Shabbos, so I don't want to. Can't carry my money and can't lock the door. But it could happen. It is called, so centralized would be the opposite. We say, no, put all your money in this safe and lock the safe. And then but of course, if they found the combination for the safe, they get all your money.
You have multiple things, multiple combinations.
Well, then it would be like the first one, yeah.
Higher dimension.
But the question is, you have limited resources. So do you buy the super good safe that costs them $10,000? Or do you buy 10 medium safes that cost $1,000 each? You see what I'm saying? You can't say, well, buy 10 safes at $10,000.
We put the safe in the safe in the safe. Safe side.
That's the one, that would be called a centralized security architecture.
Centralized access.
Unfortunately for the empire, the rebels managed to break the security and then they got everything. In trying to stop them, the empire destroyed their entire archive of system documentation in order to try to prevent it. Had the empire chosen a distributed security architecture with different parts of the death plan and stored in different locations, then stealing the plans would have been more difficult. The rebels would have had to breach security in all locations to steal the complete plans, like in Raiders of the Lost Ark, where the map was burnt into the hand of the Nazi, but only one side of it. You
I
remember?
still don't remember that. That's kind of unfortunate, but I remember. I apologize.
You saw the movie?
I did. I'm ashamed that I don't remember it.
You don't remember the Nazi grabbed the emblem from the fire and it was very hot and it burnt his skin.
I just remember the golden heart. Burning out.
Yeah.
At the end,
When
they're very scary. You probably saw it. Yeah,
those on their faces.
Massive warehouse.
yeah, that, you see, that's a good way to hide. That's the best way to hide. Somebody was talking about they said, like, why do the Sephardim read the Zohar all the time? And the Ashkenazim say, don't read the Zohar, only if you're over 40 and learned all of Shas. And yet the Sephardim read it all the time. So they said there's 2 ways to hide something. One is you hide it, you tell people, no, you can't have it. And the other is you put it on the table. You just put it on the coffee table, a lot of other letters, and you just stick it there, and it's right there, so nobody even notices that it's there. Another way to hide things.
Wonder if that's how they solve it.
That's how they what?
The CTF.
Someone go tell that. Someone go tell that.
No, it's nothing to do with CTF. CTF is impossible, put it that, in my opinion.
You've seen it?
Yeah, I did it with the girls,
Is it possible?
It's impossible.
in my opinion.
Did someone solve it?
So the people at the CPF should get.
Well,
Yes.
you know, it's possible because at a certain point, after breaking your head for 45 minutes, then the people who run it will say, like Avi will say, we'll give you a hit. So then they do solve it, maybe they do solve it,
There's
but
no way I'm just giving anyone.
he gives
No,
them.
it wasn't going anywhere.
You know what he did as a hint in the girls? He played the music from Peter Pan,
That's so. And it wasn't wrong in this.
and that was hopefully a hint. So the girls were like listening, getting a sample of the music and then putting it to Google and then figuring out that it was Peter Pan, and then like, it didn't help them at all. But no, I gave hints, he basically has that. And then like,
Oh, the girls.
I didn't know the solution, so I told some girls, oh, try this thing, I think it's gotta be like this. And then Avi overheard me and took me aside, and said, no, you can't tell them that, because that makes it impossible for them to solve. I said, well, it's an idea, I don't know the solution.
Right.
So anyway, so I went back and told them, don't do that. In other words, it's not, it's like it's like an escape room. But it's very difficult.
How does that work on, is that on a computer?
Like you embed things and
Yeah, it's
in the metadata, not even metadata, metadata.
It says to them they have to make a connection. Basically, he tells them through hints that they have a black box that's connected to the electricity, and they have to try to communicate with it, and without connecting any cable to it. So it's obvious that if you're going to communicate with it, you have to use some form of network communication. So what would you think to use?
Wireshark.
Oh, so a lot of them thought Wireshark. They'll use Wireshark, but Wireshark is more for plugging things in.
So you can get off Wi-Fi.
What?
You can get off
Wi-Fi. Okay, what else would you?
Wireshark, you can see.
Go on Wi-Fi.
You can see everything on Wi-Fi. Okay, so what if I told you that that won't help you? Wi-Fi is not the method,
Bluetooth, there's Bluetooth.
so that's the method.
Text.
Wait, when did they start though?
But is that not like,
They started a while ago, no?
well, you should turn on your Bluetooth on your phone?
No,
Okay.
but it won't, but he hid it.
You-
If you turn on your Bluetooth on your phone, you won't see it.
Huh.
It's nameless. It's a, when you turn on Bluetooth, you see the names of devices?
Yeah.
He gave this device no name. So you won't, so your phone won't see it.
What is it? It's like
So good luck finding that.
What's the?
First of all,
I
and
didn't even realize that.
first of all, he suggest, and in the hints that he gives you printed, he doesn't suggest Bluetooth, he suggests 3 or 4 other types of Tikshoret communication, hardwired Tikshoret, radio Tikshoret, he suggests 4 other types without suggesting Bluetooth.
Walkman. FM.
And it's none of those, and he says, well, you were supposed to figure out that the one I didn't mention is the one you should try.
So awful.
I'm just saying, good luck, it's just not really possible.
I don't.
Why would you ever think, you guys thought of it because you weren't distracted by the hints that are false hints, you know what I mean? No, but it took them a long time to think it was Bluetooth,
When they come.
and then once they thought it was Bluetooth, they still didn't know how to connect to it. And it turns out that the only way, whatever, you can't connect to it with a phone.
No.
It's programmed to only connect to a certain device which you gave them, but whatever, it's just like. So if you would try to detect it with your phone, just to see if it's there, it wouldn't work at all. So you would think
Yeah, I
that
can
there's no
understand.
Bluetooth,
I don't respect the clue.
you don't respect the clue?
The clue that he was like named everything and you had to figure out what was the one that was missing.
Yeah.
Does Peter Pan have to do with Bluetooth?
Tinkerbell, I don't know, Tinkerbell,
Flying.
she's flying, I don't know,
You didn't know that Captain Hook.
Neverland, dude.
I don't know. What
Never wanna grow up.
Okay,
The Lost Boy. Don't come.
okay, everyone got the idea of the centralized versus distributed architecture. So maintain.
What program is it?
Here, look at this picture, a shared database, see this shared database, C1 and C2, component, C stands for component. And they have a user interface. Assume C1 runs slowly because it has to reorganize the information in the database before using it. So the only way C1, to make C1 faster might be to change the database. But this means that C2 has to be changed, which may potentially, in other words, what if I have like in such a situation like this? That they're both using the same database, but because of the organization of the database, C2 runs fast, but C1 runs slow. So I might reorganize the database so C1 can run fast, but then I'll have to rewrite C2. C2 will now have a different, have to know how to talk to a different database. So that's a problem. So we could do a different architecture. Look at this architecture. Here, each one has its own database. The database for C1 is optimized for C1's use, and the database for C2 is optimized. What's the problem? What's the price I have to pay? There's no best solution, there are only trade-offs. What's the trade-off here? I have to have the database reconciliation component. Do you see that in the picture? The C3. In other words, because there could be inconsistent, now that I have two databases, it could be that C2, remember, it's the same information as the shared database. Here it's, let's say, a shared database, which means they're both writing the same information. If one writes, the other one will know about it immediately because it's shared. Once I separate them, the changes have to be propagated. So I need some propagation device here, and that's C3. That's the trade-off. A multi-database may run more slowly and may cost more to implement. It needs a mechanism, which is called component 3, to ensure that the data from C1 and C2 are consistent. Okay. Issues that influence architectural decisions. So, well, architectural influences are these 5 things. We're going to talk about them one by one. Non-functional product characteristics, such as security, performance that affect all users. If you get these wrong, your product's unlikely to be commercial success. Unfortunately, some characteristics are opposing, so you can only optimize the most important. In other words, we want the program to be secure and to perform fast. Those are opposing desires. Because security, like in order for me to log in here at Machal Nev, I got to do like 6 steps of security. That means that it takes me longer. So performance gets affected by security. Product lifetime. If you anticipate a long lifetime product, you will need to create regular product revisions. You therefore need an architecture that is easy to be evolved. Software reuse. Save a lot of time and effort if you can reuse large parts of your software, so you want these components. Or use open source software. However, this constrains your architectural choices because you must fit your design around that the software is being used. In other words, if you're using a component that already is existing, then you have to make your other components be able to communicate with it. So that may limit you. If you're developing also a number of users, if you're developing consumer software delivered over the internet, the number of users can change very quickly. This can cause performance degradation. Unless you design your architecture so that your system can be quickly scaled up or down. In other words, you need to be able to add servers and have the system work faster when you have added servers. Right, you all realize that websites nowadays, they have a flexible number of servers. As the number of clients attaching to the server increases, they employ more servers, and then they stop using them when the people go down. That way, you're basically renting service. That means you have to have a way to create a server in software. In other words, I run a program that brings up a server, that installs a server. I ask Google for the next day, I need a new server, and it's blank. I need to be able to copy an image onto that computer so it'll be usable. Software compatibility. For some products, it's important to maintain compatibility with other software so that users can adopt your product and use data prepared to the system. This may limit the architectural choices. In other words, if people have data in a certain format, my system needs to be able to accept that format, and that might affect the design of my system. So these are all things that I should think about, that I should consider when I am coming up with my architecture. There's a trade-off between maintainability and performance. Because. I don't know, somebody was once telling me that like a car, like whatever, if it's easier to maintain, it can sometimes perform worse. If you just seal the engine. Maybe it'll run better, but it'll never be able to improve. Maintainability is an attribute that reflects how difficult or expensive it is to make changes to a system after it has been released. You improve maintainability by building a system from small, self-contained parts, each of which can be replaced or enhanced. So that means the system should be decomposed into fine-grained components. However, having the more fine-grained your components are, there's time that takes to communicate between them. So if you have many components, your software will be slow. So it's a trade-off between maintainability and performance. What about the maintainability, security, and usability? Well, that's obvious. The more I have to authenticate, the slower, the more difficult it is to use the system. I might not want to use it if I have to put in so many passwords. In fact, the layers might include system authentication. In security could be what's called a cross-cutting concern, which means it cuts across many layers, many parts of the. You may have security in each module. Architecturally, you can implement each of these layers as separate components. If one component is hacked, the other ones could be still safe. So that means you're going to have a lot of security, but it's going to slow down your system. Here you see layers of authentication. If I want to get to a certain server, I first of all have to be coming from a certain IP. I can say only people who come from a certain IP can get into my server. Then in the software, I can, before they can even use the software, I can maybe ask them for a password. And then if they want to use a certain feature, I can ask for another password. And then I can encrypt everything. And then finally, if they get through all that, then they get to the actual information like credit card. A layered approach to security affects the usability of the software. As we just said, users have to remember information like passwords for that is needed to penetrate a security layer. So that'll slow down your interaction. Many users find this irritating and often look for workarounds so that they do not have to re-authenticate to access system features or data. To avoid this, you need an architecture that doesn't have too many security layers, and doesn't have unnecessary security, and that has components that reduce the load on the users. So in other words, don't just throw more and more security, it can make your system not friendly. Availability versus time to market. This is a strange trade-off. The availability is particularly important to an enterprise product, such as products in the finance industry, where you want them to be available all the time. You want your bank, you want to be able to check your, take out money from your bank at all the times of the day. That's called uptime. You want the uptime to be maximal. Availability is normally expressed as a percentage of the time the system is available. So there's some banks that, like on Sunday night at 1 o'clock in the morning, they're not available because they're doing documentation or reboots or backups. Architecturally, you achieve availability by having redundant components. What if you want really reliability or availability, you'll have multiple components so that if one fails, because things do fail. Imagine if a system that fails only once a year, but let's say your server fails only once a year. But let's say you have 3,000 servers in your system. Then how many failures will you get a day? You'll get about 10. If a server fails once a year, and you have 3,000 of them, then you'll get 10 every day. 10 failures every day. So your failure is something that you have to plan for. What?
Pretty good batting average.
Good batting average? Availability is normally expressed as a percentage of the To make use of redundancy, you include a sensor component that detects failure and switching components that switch operation to a redundant component when the failure is detected. So in other words, If I'm trying to connect to a certain server and I'm not getting there, I assume it's failed, so I try to a different server. Implementing these extra components takes time and increases the cost of system development. You have to now develop a whole system for failover. What to do when a server fails. It adds complexity to the system and therefore increases the chance of bugs and vulnerabilities. Now, as if I just had it all on one server with one database, life would be simple. But for various reasons, I'm not going to do that. So it's going to take me longer. Time to market will take longer in order to guarantee a system that's available more percent of the time. Architectural design. How should the system? How could architectural design questions? How should the system be organized as a set of architectural components where each of these components provides a subset of the overall system? The organization should deliver system security, reliability, preferences you need. How should these architectural components be distributed and communicate with each other? What technologies should you use to build the system and what components should be reused? Abstraction in software design means that you focus on the essential elements of a system or a software component without concern for its details. At the architectural level, your concern should be for the large-scale architectural components. Decomposition involves analyzing these large-scale components and representing the set of finite components. Layer model are used to illustrate how a system is composed of components. Here's an example of databases, database 1, 2, 3, 4, and 5. That would be the lowest level basic service. This is just an example. Web browser, user interface management. What would the web browser do? It does user interactions. User interface management might do the authentication. Information retrieval is going to allow you to search and retrieve the document. Document index might be like that I create an index of a document so that I can search it faster. Right? When you search it, you index a document, which means you turn it into keywords so you can search it better. Anyway, these are layers. This is an example of a layered approach. Complexity in a system arises because the number of and the nature of the relationship between the components in that system. When decomposing a system into components, you should try to avoid unnecessary software complexity. How do you avoid complexity? 1 is localized relationship. 2, reduce shared dependencies. What does it mean localized relationship? If there is a relationship between component A and B, these are easier to understand if A and B are defined in the same module. Better to have as little coupling between, right? As little coupling between components as possible, and as much. What's the other word? What's the opposite of couple? We want as little coupling and as much. No, cohesion. Cohesion within the module. That it should be a cohesive unit. That the parts of it should all be functioning for more or less the same goal, and not be extraneous. There shouldn't be nothing extraneous there. Reduce shared dependencies. When components A and B depend on some other component of data, complexity increases because change to the shared component means you have to understand how these components affect A and B. So you don't want to use some other component. That's the same thing as saying we don't want coupling between components. We don't want the components to be affected by each other. It is always appropriate to use local data wherever possible to avoid sharing data if you can. Examples of component relationship. A component can be a part of another component, it can use another component, it can be within another component, and it could just share data with another component. So some guidelines for architectural design are to separate areas of concern, have stable interfaces. That's what I talked about before. Stable interfaces is that the API, by creating an API, then if the component changes, the interface didn't change. Implement once, avoid duplicating functionality at different places in your code. Don't have multiple places in your code. Each component, you might have to have something like a sorting algorithm in each component, but that's bad. Ideally, you'd have one place in your code that does the sorting. Separation occurs, organize your architecture into components that focus on a single concern. Each component, I should be able to give to a group of people, and they should be able to write it, and it should all work without using any other components. So that means all the concerns that deal with one topic should be in that component. Or also, maybe together with that, you should say that the features that are related to each other should be in the same module. Okay, so we talked about layers, so here's some good design guidelines. And layered architecture. Each layer in a layered approach is an area of concern and is considered separately from the other layers. The top layer is usually concerned with user interactions. The next layer down is user interface management, and the third layer, information retrieval and so on. Within each layer, the components are independent and do not overlap in functionality. In other words, one layer does its job without recourse to the other layers. The lower layers include components that provide general functionality, so there is no need to replicate these in components at a higher level. Basically, any service that the higher level needs, you should get from a lower level. The architectural model is a high level model, does not include implementation information. Ideally, components at level X should interact only with the APIs of components at level X minus 1. Which means a lower level. That is, interaction should be between layers and not across layers. In other words, if I have several functions in layer X, those functions should call only functions that are in layer X minus 1. I mean, within reasonable limits, obviously. Sometimes there'll be some small helper function on the same layer. So cross-cutting concerns I mentioned before, and these are things that can't be separated between the layers. These are concerns that are relevant to all layers. Every layer has to take them into account when they are inevitably directions between layers because of these concerns. For example, security, performance, and reliability. Security is something that can be implemented in all layers, and it concerns all layers, and performance also. I don't want, if one layer is slow, then the whole system is slow. I have to make sure that I have good performance in all the layers. Okay. We explained that. Yeah, security, architecture, different technologies are used in different layers, such as SQL. Such as an SQL database or a Firefox browser, attackers can try to use vulnerabilities in these technologies to gain access. Consequently, you need protection from attack at each layer as well as to have protection. For example, let's say you have a JavaScript function that checks the username when he gives it to you. And if it's not a username that in your system, it reports back, sorry, there's no user like this. When the JavaScript eventually calls the backend should not assume that that username exists. It should again check it, even though the upper layer already checked it, the lower layer needs to recheck it. Because some unscrupulous party could try to go into the lower layer directly without going through the JavaScript. So that's an important principle in security. Each layer should not rely on the security checks that the previous layer did, because the hacker could try to directly access the lower layer. All right, I'll skip this. It's just an example. This is just an example of security being implemented in the browser and in the backend. Okay. And this is another example. I'm gonna skip this. The distribution architecture of a software system. So you can look at this example on your own. This is just a particular example that they did for a program that's called iLearn, which is like something like Moodle. The distribution architecture of the software system defines the servers in the system and the allocation of components of those servers. Client server architecture are a type of distribution architecture that is suited to applications where clients access shared databases and business logic operations on that data. In this architecture, the user interface is implemented in the user's own computer or mobile device. Functionality is distributed between the client and one or more server computers. So in a client server architecture, some of the functionality, some of the computations are done on the server side and some are done on the client side. If nothing's done on the client side, then you call it like a dumb terminal. But usually you distribute, especially on an app. An app is designed to do some computations on your phone and some of the computations to do on the server. For example, well, a website also can do that. Okay. Here's an example of a client server architecture where we have a pool of 6 servers. We have a load balancer. Everyone heard of the term load balancer before? Anyone heard of the term load balancer?
It balances the load,
It's a good guess.
meaning give a lot of response and requests, so we have to make sure that it doesn't override or overwhelm the system.
Well, the load balancer won't help with it.
That load.
But if it's balanced, it can still overload it. It's just because if I put too much stress on all the components, it's still great.
Wait a minute,
No, that's not the main job of the load balancer. The main job of the load balancer is to evenly distribute the requests. It's not necessarily, it could also limit the requests, but that's separate. Why it's called a load balancer is because we're talking about distribution of the requests. So that I have 2 clients with 4 clients here with lots of requests, or many clients. And the 6 servers, so it could be that each server, there could be many clients. Let's say there's 600 clients, so each server might handle 100 clients. And the load balancer will make sure that the balance is even. That they don't have a situation where one has 0 and one has 200. Now. What do the arrows mean? Look, the request comes in. Why is one arrow longer and the other, why is one direction one long arrow and one direction 2 short arrows? Why is one direction 2 short arrows and one direction 1 long arrow?
Because the load balancer, the servers are sending to one client.
Yeah.
This-
Once the load balancer's job is to assign you one of the 6 servers here. So therefore, your request comes to the load balancer, not directly. And now, not directly to the servers. And now the load balancer says, okay, I'm going to send your request on to server number 6, or server number 1. Now, once this request has come, that server will, there's no reason to go back to the load balancer. He's just going to go directly to the client and tell him the answer. Here is a model view control pattern. Have you heard of this pattern? Probably the most common architectural.
I think we used it in
You probably did. In where?
MIPS, we had a controller.
No, that's something else. You may have used it in the prequel to this course, the
Mini project.
introduction mini project.
Oh,
We're doing that now.
The controller. You see, what is the model? This is called a model view controller. So here's control. Here's view, and here's model. What is the model? The model is the data. The actual data. The view shows the data to the browser. So the browser can actually show you the view, but it creates the page for the browser to access. The controller can modify the model. According to this diagram, the controller can modify the model, which means modify the data. The view, according to this, can also modify it. This is a bit strange design here to me, because it shows that both the view and the controller can change the data. normally you would think that the view can't control the data, he has to request the controller to change it. Why would you want the view to request the controller to change the data? Because then you could limit the view couldn't do something, we could filter it, we could only allow certain types of requests to go through. If the view is maybe directly responsive to the browser. Anyway, this is the model view controller type. Client server communication normally uses the HTTP protocol. And here we should talk about, what we're gonna talk about, well, we should talk about RESTful. You learned RESTful communication? No?
I think RESTful and like a REST API with like get.
Yes, exactly. I guess I
Operation.
may just say no, I never heard it.
Yeah, I don't think people run it. I don't think we run it in class.
So we were mentioning it kind of. Client server communication normally uses HTTP. See, basically what happened is HTTP was a protocol invented just to show web pages. All it was designed to do is I say give me the file and post or post this data and then get the file. And it was basically just a way of sending data to a server and getting back data. So that was like sending a letter and receiving a letter. Now, the data was just supposed to be display data. But the idea was that, well, since we have this protocol HTTP and it's already working, let's use the get and the post for sending server requests, not just data. And that's the idea of RESTful communication. But wait, before we get there, the client sends a message to the server that includes an instruction such as a get or a post, because it has to be some kind of HTTP request, along with the identifier of a resource, usually a URL. So here's a URL and a get or a post on which that instruction should operate. The message may also include additional information such as information collected in a form. That's just your normal HTTP request. HTTP is a text-only protocol, so structured data has to be represented as text. If you want to have structured data, like you want a certain piece of data that represent the item number of an item, for Amazon web. So you have to create your own symbolism, your own symbolic language, because HTTP doesn't have that. So you have to use, and it has to be in text. So I can say, I can have it. So they invented XML for that purpose. There are two ways of doing this. One is JSON, and one is XML. XML basically uses tags that look like HTML tags, but they're user-defined HTML tags, such that I can define it as like Amazon. I can have inside of angle brackets. I can have Amazon's item number, and that'll be a specially designed, a specially created tag, which does not exist in a normal HTML. But I can create as many as I want, and as long as the other side knows how to interpret it, then the communication will work. He'll look for a flag, he'll look for a tag called Amazon item number, and he'll know what to do with it. That's the idea of XML. XML is a markup language with tags, just like HTML. JSON is a simpler representation which uses colons and semicolons, or colons and commas to differentiate between the value, what is it called? Fields and values? No, not data. Forget the term.
Is it Q value? I think it's.
Key and value. That's what you use. Key and value. JSON is like a key colon value. Next key colon value. Whereas XML is a tag, and in between the two, the opening and closing tag, you have the value. They don't have an example of it here. No. Okay, let's go back here. Wait, here, let's show you an example. I gotta show you. XML versus JSON example.
We worked with XML. It's sure. Neural is really JSON.
Here. All right, you see these two examples? It is XML versus JSON. So you see here, here's XML, you gotta say the version number. And then you say data set, see, data set is like, this is all the data set, right? A data set is like saying, this is the following is the data set. Here's a record number 1, record number 2, record number 3. I have all these different records. And if you notice that every record starts with a angle bracket word record and a close angle bracket with a backslash to indicate the end of the record. So you see, we're using these, I don't know if you know HTML, but if you do or don't, this is what an HTML tag looks like, except there is no HTML tag called record. There's an HTML tag called B, or called A, or an HTML tag called center for centering text. But there is no HTML tag called record or called first name. These are just things that I invented in this example invented. So they're like fictitious HTML tags, but from the perspective, but HTML was written in a way that if you put something in a tag and it's unknown, it's gibberish, let's say, then the browser ignores it. It ignores the tag, but it doesn't ignore the text. So in other words, from the perspective of the browser, it's though I wrote some gibberish tag here, and then the word Kyle, and then some other gibberish text that it ignores. And as if I would write here center, then it would center the word Danzig. If I write instead of last name, I write center and close center over here, then it would center because it knows what to do. Whenever it doesn't know what to do, instead of giving you an error, it just ignores it and just prints the text Danzig without any. So from the perspective of HTML, this is acceptable. It just doesn't mean anything, so it just ignores it. But it really does have a meaning it does have a meaning because the server is written in a way that he sees something called ID and he knows what it means. That's the ID. He knows first name and last name. He's looking for those things. Now the JSON way of doing it is the same exact thing, but here you say data set colon braces and then record colon, and then these are all going to be records. You see it's a little bit shorter. I do record colon and then a bracket, and then inside each individual record with commas separating them. And ID colon what? First name colon Kyle. Instead of writing first name as a tag, I write it as like a something colon. And then the value, and I use commas. So there's commas between everything, and there's colons between everything. And there's also a hierarchical structure where a data set contains records and records contains individual records. So that's these are both valid, they both work, they're pretty much equivalent, just different styles. XML is older, JSON is more new. So that's what it says here. You use XML or JSON. Now here you have a multi-tiered client server architecture. The clients are all going to the web server. The web server is just really an interface. It's just like a front end to an application server, and the application server actually goes to the database. But notice that these are all different servers. So there's a communication going on over, TCP between this server and the final server. There's something called a service-oriented architecture. Not as opposed to client server. Client server means, like we said, a client does some of the computation, the server does some. Generally, client server, the server does most of the work. Service-oriented. Service in a service-oriented architecture are stateless components, which means that they can be replicated and can migrate from one computer to another. They're just like little components. What does it mean by stateless? Stateless means that they don't keep track of state, and they'll always respond the same way to the same input. That's the definition of stateless. I mean, well, not necessarily, it could be a random function. But that the state that you're in has no influence on the reaction and the response you get. For example, let's say I've gone through various states until I'm finally at the checkout of buying cat food on this website. And now I put in my credit card information. Now, the credit card information that goes to a server that handles the credit card. He doesn't really care what state I'm in. He just, if you give me this information, at a fee, basically there's this server, which my cat food company doesn't even own. It's my payment server, and I send to it your credit card name, your credit card number, the expiration date, the amount I want to charge, and my name as being the person who's going to get the money. And I send all that information to the credit card company server. Or it's not even a credit card company server, it's a payment server. It's independent because they may handle multiple credit cards, multiple companies. And they will now make the payment and send the money to my account. They're stateless. Why are they stateless? They don't care when I am asking this request. Anytime I give this request with that information, with all that information, they will either approve they will either transfer the money or say it failed. They're stateless. Now, what does he mean by it can be replicated and migrated? Let's say all of a sudden my sales triple and I need a lot more. I'm asking them for a lot more sales. They all of a sudden notice they're getting a lot more requests. They multiply their servers. They don't have to have like it doesn't matter which. How should I say it? They just multiply that service. That's that whole service that handles a request with all that information and response. They just create more servers that can handle those kinds of services. And it doesn't matter if I buy 6 things in a row. If I bought, doesn't matter that it doesn't keep track of the fact that last time I asked for a request, it was from this credit card, so it keeps the credit card information. It needs all the information every time. It doesn't matter that I previously did the authorization by server number 1, and this time I'm doing it by server number 6. It doesn't matter which server I go to because each time he's getting all the information that he needs. I'm giving him a full basket of information every time. So I can then migrate from one server to another. As opposed to another approach, which would be no, you set up a live connection to that server and you maintain that connection and if you buy another thing tomorrow, it already has your information. So that's the idea of stateless. And we want statelessness because it allows us to replicate and migrate. You understand what I mean by replicate and migrate? Replicate in the sense I can make more servers. And migrate means now that I have more servers, I can go to a different server next time. Many servers may be involved in providing a service. Right, a service is a big thing. Like I said, giving all the information and doing the actual processing of that request. A service-oriented architecture is usually easier to scale as demand increases and is resilient to failure because I can have multiple servers. At my payment authorization company, I have many servers. And if one fails, it doesn't really bother me. Even if it takes me a week to bring them up again, I have so many others. I can handle a failure, and also I can scale. I can make more of them. And again, a service is a big thing. Like I said, it provides a whole complete service. And when we say service-oriented architecture, what we're saying is, well, couldn't I write a program? Couldn't I write a architect or write a program that basically looked around on the internet for all the services that there are, and like Legos, built my software out of all different services that already exist. I use this guy's service for that, I use that guy's service for some other thing, and I make a software which is completely dependent on external services. That would be a service-oriented architecture. I didn't do anything myself, or I did very little myself. Now here you could see that my web server has to go, let's say it has many services that it wants to use, services 1 through 6, in order to get my job done. I may go through a service gateway. Well, right. I may directly talk to this service and directly talk to that service, but I may also go through a gateway. The idea of a gateway is that there may be somebody who provides many services. Let's say he provides 6 services. And I don't want to talk to each of the what he's doing internally in his company that provides me with 6 different services. And the way I explained to you before is I said I can go to different companies, that's one possibility, this is a different possibility. I have one company that provides 6 services. And I don't wanna know about the names of each of those services and exactly which servers they are on. I go to a gateway and I say, I want now a service called credit card payment. Now I want service called a driver's license authentication. Make sure this is really a proper, whatever service it is. And I don't know the existence about the existence of these servers. I just know about the gateway, and I give the gateway my request, and this is of course what we called earlier in the class a level of abstraction. Because if I replace this server number 2, with a different server to do that service, only the gateway has to know about it. I, as the user, don't have to know about it. If this server changes its IP, I don't care. I'm still going to the same IP, the gateway. So that's called putting in a level of abstraction, which means that I'm divorced. I'm not directly connected to those servers, so it gives me, as a web server, it gives me certain freedom. Okay, issues in architectural choice. Data type and data updates. If you are mostly using structured data that may be updated by different system features, it's usually best to have a single shared database that provides locking and transaction management. In other words, we would like to avoid a situation where the same piece of information is updated simultaneously twice, and there's no way to lock it. Because if it's on one server, I can lock it. I can say, well, you're updating, nobody else can update it. But if that same data exists on 3 different servers, how am I going to lock it on all 3 servers? I can lock it on the one server. I don't even necessarily know you're updating it on the other server.
It's probably like GitHub, like when you update things.
I don't use GitHub that often, so I don't know, but it could be that it doesn't lock properly.
Merging branches.
Merging branches, no. Yeah, right. Well, GitHub actually does have some kind of what if 2 merges happen at the same time? So it will force only one to occur first. It won't allow that. If 2 people press the button to merge at the exact same moment, one will get in there first and have to wait for the other one to finish before the second merge will go. That's called making an action of time. But that can only be done because it's all on the same server. But what if I had a distributed Git on many servers, all the same information? Then how would I know to lock you from doing a merge while I'm doing a merge? Okay, if the data is distributed across systems, you need a way to keep it consistent, and this adds overhead to your system. Change frequency. If you anticipate, so anyway, ideally we want everything on one server. If we can't, we have to have a locking mechanism. I mean, if we do, we can have a locking mechanism. If we have it on multiple servers, then it'll be more difficult to have a locking system, and we really can't have a locking system. What we'll do is something called rollback, or a logging system. We'll log the changes, and then we'll have what's called eventual consistency. We won't have immediate consistency. Maybe we'll talk about that another time, but that's another idea. You have eventual consistency. You can't maintain consistency constantly. If you anticipate that the system components will be regularly changed or replaced, then isolating these components as separate services simplifies those changes. In other words, if you're going to all the time be updating your component, it's going to work in a different way next year. Then it's nice to have it as a separate component. The system execution platform. If you plan to run your system on the cloud with users accessing it over the internet, it's usually best to implement as a service-oriented architecture because scaling it is simpler. That's our alarm. We have yeah. If your product is a business system that runs on a local server, then you might want a multi-tiered architecture, which we didn't talk about, but you might want a multi-tiered architecture. Which just means local servers, but not on the cloud. All right, we're almost done. We'll come back after the break.
Push 7.
It's almost finished. We were mentioning the difference between different kinds of databases. This is a good example of look at this. This is a SQL database, or MySQL database. Typical database has, let's say, user ID 1 and 2 for Alice and Bob, and their email and their phone number, and this is a table. And then we may have another table. That's a table called users. Another table called addresses, where actually, what does this table indicate? What are these addresses associated with? 123 Main Street and 456 Oak Avenue, whose address are they?
Presumably number one, but that's.
Right,
what
Alice.
Alice is two.
Alice's to address, well, could be, why not?
Just fits like that.
She lives half the year, yeah, she's like Trump, there's a house in Manhattan and a house in Palm Beach. Or in this case, any town and otherville. So. That's a database, that's the database, that's a SQL, what about? A NoSQL database, how is that? There's such a thing as called a NoSQL database, a prime example of that is the MongoDB. So here, how MongoDB uses something like a JSON, but it calls it a BSON. Because it's a binary encryption of the data, as a binary version of the data, but I mean, like I always say, all files are binary, but whatever, instead of being ASCII, it's some other description, so. Here, we have MongoDB's unique identifier, here's this object ID. And it's this long string, and that's the identifier, but then you see. First name, so that's the unique identifier, fine. And then you see that her name is Alice Smith, and her email and her phone numbers. And then addresses, and then inside the addresses, we have address 1 and address 2, and this is a JSON, this is all JSON format. And then we have another ID for Bob, and he has no addresses. So if you see, this is a different kind of database because it's not relational. What does the relational database mean? It means that there's different tables for different things, and then they relate to each other. That's why it's called relational. You have a code, you have an ID that links between them, but they're different tables. Here we have just like one huge table, and all the information is stored together, but in a kind of structured way. That's a different type of database. What's the advantage of these? Well, the big advantage of this, if you think about it, well, one big advantage, I would say, is that you can cut it up into different disks. In other words, I wouldn't want to cut a table into two different, if I had a single table, it's very large. I would have to search. I don't know, it's not easy to divide it up. But I can't think of a good way of explaining it right now, but it's not easy to divide up a table between two different disks. And if your table is very large, like hundreds of terabytes, then you can't put it on one disk. But this kind of a thing, each piece is just another piece, so I can put them anywhere. Let's see if he says that. Scalability of relational databases typically scale vertically. While sharding can be implemented, it is complex. Sharding is what I just described, where you take a single table and you put it on two different disks, which you may need to do because your disks are, there's no such thing as disks that can hold the largest table that I can imagine. MongoDB's approach, MongoDB is built for horizontal scalability, scaling out by adding more servers. In other words, that the data is stored, spread out over many servers. It supports sharding, which automatically distributes data across multiple servers in a cluster. This allows it to handle massive data sets and high read-write loads. MongoDB has its own SQL language, it's not called SQL, it's called MQL. While it's different from SQL, it offers powerful capabilities of querying, filtering, aggregation. Fine. Anyway, fine, we're not gonna talk about more differences, but basically you should be aware that there are two types of databases. Wait, let's see. Wait, let's ask Gemini this other question, just to verify what I said. What is sharding in this Thanks. Imagine you have a single enormous bookshelf that is overflowing with books. It's becoming difficult to find anything. Sharding is like taking that one huge bookshelf, breaking it down to several smaller, more manageable books. These smaller bookshelves, a shard, holds a portion of your books, right? So it involves splitting large data sets into smaller independent pieces called shards. They're not mentioning that it can be put on a separate disk. But instead of it all residing on a single service, it's distributed across multiple servers. Well, it's on multiple servers, it's obviously on multiple disks. Okay, whatever. It is what it is. So yeah, nowadays with what we call big data. That was the old, terms always change. First we had big data, we had data mining, we had big data, then we had machine learning, and now we have AI. Just all different terms for very similar things, and then there's LLM, large language models, which is AI. Everyone likes these terms, buzzwords. Current, but all this AI and all this stuff requires basically non-SQL databases. They're more flexible and potentially more efficient than relational database for data analysis. He's saying that back in 2018. Allow data to be organized hierarchically rather than as flat tables, and this allows for more efficient concurrent processing of big data. See, that was the buzzword at the time, big data. In other words, when we say hierarchical, we saw that the JSON was hierarchical itself. Within Alice was her addresses. It's a hierarchy within each unit. Delivery platform. The delivery platform can be web-based or mobile product or both. In other words, you can go to your bank on an app or on a website. A lot of times you go to the website and they say, don't you want to go to the app? And they say, no, I want to go to the website because you don't have all the features in the app that you have on the website. And then you have to hold your whole phone horizontally to be able to use it. Because if it puts it vertically, it doesn't show you all the features. Because they're smarter than you are, right? They're trying to make it nicer for you. You have to tell them to force it. No, I want all the features that are in the website. Why did they reduce the features on the app? Because it's your phone and you can't do like how much, you want to see it big, you can't squeeze everything in. Of course, if they would think about it, they could create a hierarchical structure in the app. So you can find everything in an easy way. Anyway, delivery can be either one, mobile issues. So what's the problem with mobiles? Intermittent connectivity. You must be able to provide a limited service without network connectivity. In other words, I can still use my Maccabi Health app. If let's say I logged in and then I lose internet connection. But it already put down a bunch of data so that I can see, let's say, if I all of a sudden decide I want to see what my appointments are, my doctor's appointments are, or my children's doctor's appointments, I can see them because I have all the data there. It's already been downloaded. So I have some kind of limited, but if I try to cancel an appointment, it won't let me until I reconnect to the network. A web-based one, well, might not care about that, might assume that you have a really good connection and not assume that, and might not download all the, as much information right away. Processor power, mobile devices have less power processor, so you need to minimize computation intensive operations, right? You have to expect that the computer will do less, that the app will do less computing than the website might, because the website might have JavaScript, which will offload some of the computing to your computer from the server. We discussed that before. That one of the purposes of JavaScript is to offload the computing processing from being on the server side to be on the client side, which allows the server to be less burdened. And that's desirable if you're your own server. Power management, you wanna limit your power use, which is related to computation. We don't wanna have it running all the time doing complicated computations, you want it to go to sleep. On-screen keyboard, you need to have an on-screen keyboard and they're prone to errors, so you should probably have some kind of error, spell check, or you should minimize input using the screen. I don't know what that means. In other words, the input should be clear, like instead of lots of little buttons, maybe one button and then you go to another button and another button. A lot of times when you go to a website, it's very annoying. In order to like buy something, you gotta click. You gotta fill in these things and then click next, and then fill in things next. And why is that? Because the website is actually designed to be viewed on a mobile device. And in a mobile device, you can't fit too many things on your screen. So the next is better. So it's better if you have a few things and then the next step and the next step and the next step. It can be annoying, like if you're on an actual computer, you might want it all right in one page. To deal with these differences, you usually need separate browser-based and mobile versions of your product in front of you. So it's better not to do that. Better not to do what I just described, where you have one version that's for everybody. You should design it, and in fact, sometimes you have to design a front end for an iPhone that's different from a Galaxy. You may need a completely different decomposition structure in these different versions to ensure that performance and other characteristics are maintained. Fine. Server. A key decision that you have to make is whether to design your system to run on customer servers or to run on the cloud. When he says customer servers, what he means is if I'm selling a product to, let's say, the Department of Energy of the United States, and I'm selling them some software. Am I expecting them to buy their own servers and have a server room where they run it? Or am I expecting them to rent service from Amazon? On the one hand, it's easier and probably cheaper for them to not have to have their own maintenance staff of maintaining a server room and just run it on Amazon. On the other hand, they may say, well, we're the Department of Energy of the United States. Amazon is a company, and maybe they'll be hacked, or maybe one of their we don't have security. Maybe they don't have security clearance. Maybe we don't want to run it on the cloud. So you have to decide: is it going to run in the cloud, which has advantages, or are you going to run it? Or are they going to run? Is your client going to run your software locally? That'll change your software very much. For consumer products that are not simply mobile apps, I think it's almost always makes sense to develop for the cloud. For business products, it is a more difficult decision. Some businesses are concerned about security and prefer to run their in-home server, just like I said, especially if it's a government company. They may have predictable pattern of system usage, so they're less need to design to go with large changes. In other words, for example, if it's the software for an auto dealership and repair shop, like they have in Talpiot, where you go get you buy your car and then you bring your car in every half a year to be maintained, and they keep track of all the things. They have a computer system that keep track of all the maintenance that was done. When I actually bought my car almost 10 years ago now, I went to the dealership with the license plate number of the car that I was thinking of buying, and they typed it in, and they could tell me, I don't know if this is legal, but they told me, is it legal?
They have those things now, online and stuff.
And they told me whether he did all of his tipulim, if he was in an accident, did all of his maintenance by the official, owner, by the official shop, or did he do it privately and not by them? And I could see that the car that I bought was all the maintenance was done in the official shop. And he said you can buy, and you could see how many miles the car had.
They didn't tell you about the nitro boosters that were on that car.
Nitro boosters? Yeah. I don't even know what that means, but.
Well, remember that's
So I got the car.
like for drag racing.
I got the car. Because of that. And then, of course, for the first year, I did take it to the official place, but the car was, when I bought it, it was 10 years old, almost. So it was 8 years old. So I figured at a certain point, I'm not gonna go to the official dealer, so I don't go to the official dealer. But when I bought it, I made sure to buy it from the car that had gone to the official. But the point is, a company like a car company like that has a system to keep track of it, and it's not in the cloud. Because they have because it doesn't need to be in the cloud, they can buy 3 machines, you know, they can buy 2 servers. And they all can, and all the workers connect to that same one, right? They all have to be able to see. All the different workers who want to look at the computer have to be able to see the same information. But they don't need it to be on the cloud. Actually, the interesting thing was they had the same information from the dealer in Tel Aviv. The car I bought was in Tel Aviv, and that was in Jerusalem. He could see that he had gone to the dealer in Tel Aviv. So all the dealerships are actually connected. But it doesn't necessarily mean they're in the cloud. There could be one central office, which has a server room for all the country, and they connect by Wi-Fi, by internet. They don't have to be in the cloud. I can just connect by the IP number to a certain computer in Tel Aviv that has all the information of the, you know, Honda dealership information. And they have what he says here is the variance in their demands on their server is very small. In other words, it's not like all of a sudden they're gonna need thousands of requests because people are just buying cars all the time, bringing in millions of cars in to be repaired. They know how many cars they get every day. It's a statistic, and it's pretty much even. And besides, the mechanics can't handle more than a certain amount, so it's anyway limited. So they don't need to be able to expand and contract the capabilities of their service from day to day. So therefore, there's no need to do it on the cloud. And it may be cheaper to just maintain a few servers in Tel Aviv to have all the cheaper.
Cheaper to have a server.
It might be cheaper to have your own. In general, it's cheaper to have your own server. Because you can buy a server and it might last 10 years and you put a one-time expense in. I mean, you have to have somebody come in and you can actually pay for a server. Machon Lev does this, which is that you can actually, you don't have to hire somebody. Normally you may say you have to hire somebody and pay them a salary to maintain the server, but you don't have to do that either. There are services. You can hire a person, you can hire a company that whenever there's a problem, you call them and they come and check your server.
That's one of those.
That's what Machon Lev, well, they did, I don't know if they do it, that's what they did. I assume they do that still, yeah, they do that, I assume they do that.
But they have all the local. They have the local.
They have local servers, they have local machines, they're not on the cloud, they should go to the cloud.
Why?
Because you have to compare the cost of the cloud versus owning the machines and paying the service to maintain them. Whatever,
It's
it's a
one-time
cost.
expense, that's usually.
Well, no, the servers you do have to replace from time to time. And it's harder to expand, you have to buy new, it's harder to expand, and you have to hire a company to service them. It's basically like, should you build your own gym in your backyard, or should you buy a membership at a gym? In the end, it's usually better to have a membership at a gym because, yeah, usually.
And nobody has to do the back end.
People do it. Right
Oh, you mean
now,
like, oh.
I mean, like
okay,
very
okay,
rich people.
Like
Very-
like a place to work out, not like a. I was thinking of like a warehouse, but
No, like people who are very rich in California have mansions and they have a gym. But then they have to have like somebody maintain it. They have to, what if the machine breaks? They have to have,
usually cloud.
it's a one-time expense. But then you also need a maintenance. Should you buy a pool and install a pool in your backyard? Or should you membership to a community pool? Membership to a community pool